Bulla and welcome to Group 1's presentation on Git. Git is a distributed version control system. Developers may effectively manage project versions, track modified codes, and collaborate on projects. It makes taking snapshots, monitoring changes over time, and coordinating work across several machines possible. State-of-the-art for Git include the following. 1. Distributed version control allows multiple developers to collaborate on a project simultaneously without relying on a central server. This facilitates teamwork and permits offline work. 2. Efficient branching and merging. Git streamlines branching and merging tasks, allowing developers to work on distinct features or bug fixes independently and subsequently integrate them seamlessly into the primary code base. 3. Open source. Its source code is freely accessible for anyone to examine, modify, and contribute to. This environment nurtures innovation and ensures that Git remains adaptable to evolving development practices. 4. Lightweight and fast. Git is intentionally built to be lightweight and speedy, which makes it well suited for both small-scale and large-scale projects. Common tasks like committing changes, creating branches, and merging code are usually executed swiftly, contributing to overall. Moving on to the scope of Git, the technologies supported include 1. Operating systems. Git is compatible with most major operating systems, such as Windows, Mac OS, Linux, and Unix-like systems. 2. Programming languages. Git works with projects written in any programming language since it is language neutral. 3. Integrated development environments and editors. Git integrates with many popular IDEs and code editors, such as Visual Studio Code, IntelliJ IDEA, and Eclipse, through plugins or built-in support. In addition to the scope of Git, the platforms supported are 1. Self-hosted servers. Git offers complete control over the repository hosting environment when used with self-hosted Git servers, such GitLab, Bitbucket Server, and Gitty. 2. Cloud-based services. GitHub, GitLab.com, Bitbucket, and Azure DevOps are a few examples of cloud-based Git repository hosting services that support Git and include capabilities like issue tracking, collaborative development, and continuous integration/delivery, CI/CD. 3. Local repositories. Version control can be achieved without a central server by using Git with local repositories on a developer's PC. 4. Containerization. Git is frequently used in conjunction with technologies such as Docker, which allow for versioning and management of Docker. Popularity. Studies have shown that Git is incredibly popular and currently holds 89.04% of market share over some of its top competitors and alternatives. Below are Git's purposes. 1. Backup/recovery. Git serves as a backup mechanism for codebases, ensuring that no changes are lost and providing a mechanism for recovery in case of data loss or corruption. 2. Version control. Git maintains a complete history of all modifications, enabling developers to review past changes, revert to previous versions if necessary. This allows any developer to understand the evolution of the codebase. 3. Collaboration. Having a centralized repository where code changes can be shared, reviewed, and merged, allows transparent collaboration among developers. Moving on, listed below are the features of Git: distributed architecture, branching and merging, committing, remote repositories, staging area, merge resolution. In summary, Git is currently the most widely used version control system because of its open source nature, which makes it simple to use for a variety of tasks. Git makes it possible for multiple individuals to collaborate while using the same files. Additionally, it aids in the team's ability to handle the misunderstanding that frequently arises when several people modify the same file. Git copies changes from one such repository to another and gives each developer a local copy of the complete development. Furthermore, here are the advantages of Git. Distributed development, allowing several developers to collaborate on a same project at the same time even if they are not linked to a single central server. Branching and merging. Git streamlines the process of branching and merging, enabling developers to work on separate features or versions of a project simultaneously and effortlessly combine changes back together. Data integrity. Git is very resistant to corruption since it uses cryptographic hashes to guarantee the integrity of the data kept in the repository. History tracking. Git keeps a thorough history of all modifications, including who made them and when. This information is useful for troubleshooting and comprehending how the codebase has changed. On the other hand, the disadvantages are complexity. Using Git can be challenging, especially when handling complicated branching methods or resolving merge disputes. Storage requirements. Git keeps a complete copy of the repository on the workstation of every developer, which may result in hefty storage needs for large file or long-running projects. Performance with huge files. Git performs well with text files, but it has trouble with huge binary files, such multimedia or graphical files, which might cause fetching and cloning to take longer than expected. Absence of GUI. Although Git comes with a number of GUI features, some users might find it difficult to operate the program without a graphical user interface. On the contrary, here are the applications. 1. Source code management. Helps managing and tracking changes to source code files. Developers use Git to track changes, collaborate with team members, and maintain different versions of their code base. 2. Collaborative development. Git enables multiple developers to work on the same project simultaneously by allowing them to merge their changes seamlessly. This facilitates collaboration among team members working on different features or tasks. 3. Version control. Git provides a complete history of changes made to a project over time. This allows developers to revert to previous versions of their code, compare changes, and identify when and by whom specific changes were made. 4. Branching and merging. Git's branching and merging capabilities allow developers to work on multiple features or experiments concurrently without interfering with the main code base. Branches can be created for new features, bug fixes, or experiments, and later merged back into the main code base. 5. Continuous integration/continuous deployment, CI/CD. Git integrates seamlessly with CI/CD pipelines, allowing developers to automate the testing, building, and deployment processes. CI/CD pipelines can be triggered automatically whenever changes are pushed to the Git repository, ensuring rapid and reliable delivery. Lastly, these are the benefits of Git. Before Git, developers used to submit codes to the central server without having copies of their own. Changes made to the source code were unknown to the other developers. No communication between any developers. After the introduction of Git, all developers have an entire copy of the code in their local system. Changes made by other developers can be tracked. Regular communication between the developers. Final key points are the local copies, tracking changes, and enhanced communication.